Hello, this is Mr. Stansbury. I'm going to take you through the 10 E-notes on three-dimensional problem solving. At the end of this, you should be able to say that I can find various measures of 3D shapes using trig ratios. Alright, so let's jump straight into some examples. First one's example 12 from page 332. It says a cube has sides of length 10 centimeters. Find angle CBA. Okay, so CBA. So we want to figure out what this angle, oh, that's rotten. That's a little better. We want to figure out what that angle right there is. All right, so what we want to do is kind of take a look at this a little bit different way. Let's look at it as we're looking straight down on top of it. And that would be A, and that would be C. And we know that, let's see, the cube has sides of length 10 centimeters. So this is 10, and this is 10 centimeters. And this is a cube, so these are all right angles. So we need to figure out how long this piece here is, right? So really what we can do to figure that out is just do, easiest way is just a squared plus b squared equals c squared. And again, that is not 9 squared, but a squared. Alright, so let's do 10 squared plus 10 squared equals c squared. So we have 100 plus 100 equals c squared. So there's 200 is c squared, and then we square root to get what our c side is, this one here, and that's going to be the square root of 200. Now it's going to be handy to actually have a actual decimal answer here so that we can plug it in so we can figure out this other stuff. So let's figure out what that is. So we've got square root of 200, 14.1421, blah 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 blah. So let's do 14.14, and this is what in centimeters. And honestly the farther out you go in your decimal places here, the more accurate answer you're going to end up with. So we'll go with 14.14. So now we know that this piece right here, 14.14. Alright, and we know that this is 10, so let's redraw this triangle here as, if we take a look at it from the side, here's A, here's B, and here's C. Now we know that this has got to make a right angle right here, and this is the angle that we're looking for. We know that this length here is 10 and this length here is 14.14. So now we have enough information to find out what that angle is. So from that angle, this side is the opposite, that's the adjacent, so we'll do tangent theta equals 14.14 over 10. So again, since we're calculating an angle, we're going to do second tangent as of 14.14 divided by 10. Hit equals, and we get let's go with 54.7 degrees. So theta equals 54.7 degrees. So that is angle CBA is 54.7 degrees. Alright, okay, so there's our first example. Let's take a look at another one, and this is example 13 from page 334, and this is like shadow or projection type questions. So it says each of the following, so find the shadow or projection of each of the following in the base plane if a light is shown from directly above the figure. So if a light is shown from infinitely above, so basically like the sun is shining down on this, they're asking what would be the shadow of UP. So here is U and here is P. So basically they're saying, okay, if you have this line here, oh my gosh, look at how beautifully straight that was. For me, that's pretty good. Come on, you got to admit. So anyway, if you shine a shadow down on that, they're asking what would the shadow be, and if you shine a shadow straight down on that, it's going to be, for A, it's going to be TU, right? Because it's shining straight down on top of it, is going to shine right down and make this line TU. Alright, so again, you got to think of a light being shown from directly above this line PU, which would again cast a shadow on TU. Alright, for B, WP, let's do these in different colors so this is easier to understand. So B is WP, so here's W and here's P. So to make this shadow here, if it's shown from straight above, is going to be WT. Alright. C is VP, so here is V and here is P. So if we make this line here, if we cast a shadow from straight above, it's going to make the line TV. Alright. And then last one is XP. So here's X and there's P. Oh, see, that's what happens when I got all excited that I was drawing such beautifully straight lines. Oh, that one's worse. And now look what happens. Oh, justice. Oh, that's terrible. I'm going to get this right. We might be here for a while, but I'm going to get this right. Oh, gosh. Come on. There. All right, close enough. So if we make the shadow from X back up to P, that's going to make the line TX. All right, and that's really all there is for these problems here. All right, so just casting shadows. All right, so next example is find the angle that PV makes with QV. So PV, so here's PV. Oh, that's terrible. That's close enough. So PV makes with Q and V. So there is Q and V. Oh my gosh. There we go. So we want to figure out the angle that PV makes with QV. So we're looking for this angle here. All right. So let's take this triangle and kind of flatten it out over here. So we've got, here's P, here's Q, and then we'll go up here to V. So let's fill in the information that we know. So we know that PQ is 9. We know that we're looking for this angle here. We know that that has to be a right angle because it makes a right angle with this side here. So really all we need is either this side here or this side here. And honestly, I'm thinking that this VQ side is going to be a lot easier to figure out, because if we draw, if we draw this piece here, if we pull this out over here, we make this here. So this is Q, this is R, and this is V, and we know that this is 4 centimeters and this is 5 centimeters. We want to know what this is here. So again, we can just do A squared plus B squared equals C squared, and that's going to be our best bet. So 5 squared plus 4 squared equals C squared. So we get 25 plus 16. Add those together and we get 41. Square root both sides here and we get that C is, so take the square root of 41 and we get 6.40. So that's what this here is, the VQ. So that's what we're looking for there. So this here can go right up there, and that's going to be 6.40 if we're getting real technical here, centimeters. So if we want to figure out what this is, then all we're going to want to do is figure out that this is the opposite and that's the adjacent. So we'll do tangent theta is going to equal 9 centimeters over 6.4 centimeters. Okay, and then again with our calculator, since we are looking for an angle, we are going to do second tangent of 9 divided by 6.4. and we get 54.58, so let's call that 54.6. So theta equals 54.6 degrees right here, which is PVQ. So the angle, find the angle that PV makes with QV. So PVQ, angle PVQ is about, we really probably should make the little squiggles, 54.6 degrees, and the little squiggles mean approximately. All right? All right. One last example. Okay. A symmetric square base pyramid has base lengths of 6 centimeters and a height of 8 centimeters. Find the measure of angle TRM. So we're trying to figure out, let's see, we have from here to here to here. We're trying to figure out that angle right there, right? So let's, again, let's draw that piece out here as best we can. So here's T, here's R, and here's M. Let's see, what do we know in here? The only thing we know so far is this 8 here, and we know that we want to figure out that angle there. So we either need to figure out this side, MR, or this side, TR. So let's see, the other things we do know is that these sides here are 6. All these sides here are 6. Same with this one in the back. So really what I'm thinking here is if we pull out again part of this, oh gosh, that's bad. That's not much better. But that's all right. So R, Q, and P, these are both 6 sides, and then M is halfway in between P and R. So this is M. So basically, if we find this side PR, then we can take half of that, and that's RM, which is this piece right here. Then we can figure out what that angle is. So A squared plus B squared equals C squared. So 6 squared plus 6 squared is C squared. 36 plus 36 is C squared. So that gives us 72 for C squared. So we square root both sides, and we get that C equals square root of 72 gives us 8.49, we'll call it 8.49. So we really want to take half of that. So let's just take our original question here, our answer, and divide that by 2. We get 4.2. We'll call it 4.24 for R to M. Okay, so 4.24 is this here. So now to figure out this angle here, we've got the opposite and we've got the adjacent. So again, we're going to use tangent. So let's do tangent theta equals opposite, which is 8, over adjacent, which is 4.24. Right, so we're going to take our handy dandy calculator. Second tangent of 8 divided by 4.24, and we get 62.07, so let's call it 62.1. So theta equals 62.1 degrees. So angle TRM is, again, we should use the squiggles to say that it's approximately 62.1 degrees. All right, so that's all we have for that. If you have any questions, please ask. And again, you should now be able to say that I can find various measures of 3-dimensional shapes using trig ratios. Thanks so much.